Let's look at how we deal with distributed loads on our concrete bending cross-section. Distributed loads can come from things like occupancy loads on a slab or fluid or soil loads on a wall. In order to work with loads, first thing we need to do is make sure we switch to the loads ribbon. In order to place distributed loads, we need to draw them. To draw them, we're going to look at the first part of the ribbon here where we have the option to draw a rectangular load, a circular load, a tubular load, in other words a rectangle with a hole, or a ring load, which is a circle with a hole. Let's look at drawing a rectangular load first. If I select that from the ribbon and then drag my mouse, we see we're dragging a box across our cross section. This represents the area that's going to be loaded. When I let up on the mouse, the load gets created and it's selected. So if we look over in the inspector, we see the properties of the loads. Currently it's set to be a uniform load and a uniform pressure of 0.05 kips per square foot or 50 pounds per square foot. The negative sign means it's in the negative Z direction or into the plane of the view we're looking at. The result is printed above as well for that load. In addition, distributed loads have the ability to apply an overturning component as a moment either about the X or the Y axis. Using these, we'll make the load linear varying and we'll do the calculation of how the pressure should vary in order to produce these moments. In addition to a uniform load, we can also apply a linear pressure varying in the X direction or varying in the Y direction. A typical use of a linear pressure in the Y direction might be for a wall model, and we're modeling the fluid pressure, let's say, or soil pressure starting at the base of the area to the top of the area. When we specify a linear load, we have the ability then to specify the starting and the ending pressure. The coordinates where these pressures start, in this case, because it's varying in the Y direction, it'd be the Y coordinate at the start and the Y coordinate at the end of the load are displayed. And as with the uniform load, we can also apply an overturning load and add additional varying linear load to the load that we've set up above. So that's a rectangular load. In addition, for example, we can draw a circular load on an area by selecting draw a circular load and then dragging my mouse. And I can draw a tubular load. We'll do that over here. And we see we end up with a load with a hole and a ring load. We'll draw that up in the top corner here. Now if I rotate my model around a little bit, we are going to see the graphical view of the loads that we've created. Currently, they're all uniform, so you're seeing no variation in the intensity. These loads, like all objects in our products, can be selected. Once you select them, they can be modified in the inspector. You can also delete them once selected. I'll show you one more distributed type load that's available. Whenever you have a model with multiple boundaries, as we do here, we have an option in the ribbon to apply a multiple boundary load. If I select that, we'll see we've generated a load that encompasses the entire boundary. And this load, like other loads, can be uniform, it can be linear varying, and have overturning moments. So this is a quick way to apply a load to the entire cross section.